Good morning everyone, welcome to MSc, the online classes. So in the previous classes we have discussed about factorization of polynomial. In that session we have discussed what is the meaning of a factorization, and we got that factorization is a process by which a polynomial or a number can be expressed as the product of two or more numbers, and that numbers or that terms must be the factor of the previous one. For example, we can take the example of a 6. 6 can be written as the product of 2 into 3. That means if a number can be expressed as the product of another 2 or 3 numbers, then this procedure is called factorization. And you see, both 2 and 3 are the factors of 6 also. That means if we are calculating the factors of 6, 1, 2, 3 and 6, you can see 2 and 3 are also the factor of 6. That means if a number can be expressed as a product of its own factor, then that process is known as factorization. It is applicable to polynomial. In the previous classes we have discussed if x square minus 3x plus 2 can be expressed as x minus 1 into x minus 2. So here this is a quadratic polynomial, and this polynomial can be expressed as the product of two terms or two polynomials. Since it is a quadratic polynomial and the product of these two polynomials gives rise to quadratic polynomial, and we see this individual term are linear polynomial. It is a linear polynomial because its degree is 1. It is also a linear polynomial and its degree is 1. That means a quadratic polynomial can be expressed as the product of two linear polynomials. That we have already discussed in the previous session. We have also discussed if root is given, suppose p of 3 is equal to 0. That means if root is given, can we find the factor? Yes, we can find the factor because p of 3 is equal to 0 means a remainder is equal to 0. And do you know, if remainder is 0, according to the statement 2 of factor theorem, if remainder is 0, then x minus a will be the factor. And here 3 is the root. You can say it to 0. It is also known as root, or you can say it 0. That means if 0 is given, then we can find the factor. So the factor will be x minus 3. If p of minus 3 is equal to 0, so in this case the root is or 0 is minus 3 and the factor is x minus a. That means x minus of minus 3, that is x plus 3. So if root is given or the remainder is given, then we can find out the factor using the factor theorem. And third thing that we have discussed, that is the number of solution. For example, I am taking 2x plus 1 is equal to 0. It is a linear equation because it is a linear polynomial. Then since its degree is 1, it is a linear polynomial. So how many solution can it has? यार कितना solution हम पाई परिवार? You get only one solution from this. How? 2x is equal to minus 1, x is equal to minus 1 by 2. So you get one solution if the polynomial is linear. That means if the polynomial is linear of degree 1, then it has one solution. That means it has one root. That means it has one 0. That is the 0. And if the polynomial is quadratic, like x square minus 3x plus 2, since it is a quadratic polynomial and its degree is 2, that means it has two zeros or two roots, or you can say two solutions. We can write it has two solutions. That means we can get two value for x. X is something and here x is something. So these are the things that we have already discussed in the previous session. And in this session, we will discuss about how to factorize a quadratic polynomial. Okay. So today's class is based on factorization of quadratic polynomial. How can we use the procedure in order to factorize a quadratic polynomial? That means how we can convert a quadratic polynomial like 4x plus 3 into the product of two linear polynomials that we will study today. Okay. So a quadratic polynomial can be expressed as the product of two linear polynomials, as we know, and here we will derive what are that polynomial, what are that linear polynomial. Okay. So especially there are four methods in order to factorize a quadratic polynomial. Okay. So these four methods are by factor theorem, okay, middle term splitting method, you can use Sridhar Acharya method, or you can use identities. Okay, these four methods can be used in order to factorize a quadratic polynomial. Okay, and in this session we will basically learn about factor theorem only. Okay, and in the upcoming classes we will learn about middle term splitting method, Sridhar Acharya model, as well as identities method. So let's start with the factor theorem today. Okay, let's factorize some quadratic polynomial using factor theorem. We have a question: factorize this quadratic polynomial x square minus 5x plus 6 by factor theorem. Since we are going to factorize this polynomial, since it is a quadratic polynomial, then factorization means we have to convert, or we have to express this polynomial as the product of its two factors, and that factors must be a linear polynomial. Okay, that means we have to convert this into the product of two linear polynomial. Okay, that means we have to write two factors of this quadratic polynomial. Okay, so here we need factors, but in order to find the factors, what we need, as we know, if we can know the value of the zero, then we can find the factor. For example, if we have a is equal to 3, so can we find the factor? Yes, we can find the factor. The factor is x minus a, that means x minus 3. Clear? If we have the factor a is equal to minus 2, can we find the factors? These are the root. Then we can find the factor x minus a. That means x minus of minus 2. That is x plus 2. That means if we can know the value of the zeros, or we can say the roots, then we can reach at the factors. Since here we need two factors, that means we need two zeros. Clear? And one other thing is, since it is a quadratic polynomial and its degree is 2, then how many zeros can the quadratic polynomial have? Since x square minus 5x plus 6, okay, is a quadratic polynomial. So how many zeros it has? So it has 2 zeros because its degree is 2. It is understood why it has 2 zeros? Because its degree is 2. Suppose we do not know what are the zeros, or what are the value of the zeros. Suppose we will take, suppose this 2 zeros will be A and B. Okay, we can think, and we don't know the exact value of A and B. Suppose the 2 zeros be A and B. Okay, and we know if A is a factor, A is a root or 0, then what will be the factor? X minus A is the factor. Okay, and if B is a 0, then what will be the factor? X minus B will be the factor. Okay, now it is clear. Then here we can get the two factors. Then we can simply convert this quadratic polynomial x square minus 5x plus 6 is equal to first factor, that is x minus a into x minus b. This is the second factor. Are you getting my point? Okay, so first we need to find the two factors. So in order to find the two factors, we need two zeros. Since it is a quadratic polynomial, that means it has two zeros. And let us assume, okay, let us imagine that the two zeros will be a and b. If a is first zero, then what is the factor? X minus a is the factor. If 2 is a 0, then what is the factor? X minus 2 is the factor. If b is a 0, then what is the factor? X minus b is the factor. Okay? So in this way, we can get the two factors, that is x minus a and x minus b. Now, the factorization is completed. That a quadratic polynomial can be expressed as the product of two linear polynomials. Then you can see these are the two linear polynomials also, because they have the highest power 1, that means they have the degree 1. That means up to this we have completed what the question asked to do. Okay, but one thing you can see here, though we can convert the quadratic polynomial into linear polynomial, but I do not know the value of a and b. These are unknown terms for us. Okay, these are unknown to us. So let us find out the value of a and b. So our next target is to find the value of a and b. This is clear? So how we can find the value of a and b? Let us do that. Then we can write x square minus 5x plus 6 is equal to, now multiply this two linear polynomial. Let us multiply using distributive law, minus a x minus b. Okay, so finally x square minus 5x plus 6, it will be x square minus bx, then minus ax. Do not open the bracket until you solve inside the bracket. Okay, so x square minus 5x plus 6 is equal to x square minus bx minus ax. The sign will be changed, plus x. Now you can see x square minus 5x plus 6 is equal to, always write the polynomial in the decreasing order of its degree. So degree 2 will come first, then see these are the two like terms. Yes or no? Yes, because they have same variable and same exponent. That means these are the two like terms. Now let us take common as minus. We have to take common minus, and what has been taken as common? X. Okay, or you can write the x in the last. Okay, we can take minus as common from the two like terms and x as a common factor. Now if minus has been taken out from this two term, then the sign will be changed. It will be b, and this minus will be plus a. Okay, then plus a. So this is our final result that is we need. So x square minus 5x plus 6 is equal to x square minus b plus a whole into x plus a. Okay, now you can see this part is known as left hand side and this part is known as right hand side. And what we can see the left hand side and the right hand side are equal because an equal symbol has been placed in between them. That means we can say LHS and RHS are equal. If LHS and RHS are equal, then we have to compare the terms of LHS and RHS. That means you can see in LHS we have three terms: x square minus 5x plus 6. And in RHS we have also three terms. One is x square One is minus of b plus a into x plus ab. So since LHS and RHS are equal, then we will going to compare the terms of LHS with RHS. So I am writing that. So let us compare the terms of LHS and RHS. How can we compare the terms of LHS and RHS? We can compare by simply comparing the x square term with x square, comparing the x term with x, comparing the constant term with constant. Okay, are you getting my point? Comparing the coefficient of x square with the coefficient of x square, comparing the coefficient of x with coefficient of x, comparing the constant term with this constant term. Okay, so first we have to compare the coefficient of x square on both the sides. So we can write coefficient of x square of LHS is equal to coefficient of x square of RHS. Okay, here you can see the coefficient of x square is 1. Now you can see it. The coefficient of x square is 1 is equal to, and what is the coefficient of x square of RHS? You can see the coefficient of x square in RHS is equal to also 1. Okay, that means 1 is equal to 1. This is checked or verified. Now let us compare the coefficient of x, okay, of LHS is equal to coefficient of x, okay, of RHS. Now let us compare the coefficient of x of LHS with RHS. In the LHS side you can see what is the coefficient of x. It will be minus 5, and we can write minus 5 is equal to coefficient of x of RHS. Here you can see what is the coefficient of x. This is the coefficient of x. How can we get the coefficient of x? Just put your hand on x, and the remaining part you can see this remaining part are the coefficients. So what is the coefficient of x? You can write minus b plus a. Okay, then first write this term. Okay, we can write minus b plus a is equal to minus 5. Okay, since we get minus minus cancelled out, and we get b plus is equal to 5. Okay, suppose this is equation 1 and this is equation 2. Now the coefficient of x square of LHS and the coefficient of x of LHS with RHS has been completed. Now we will compare the coefficient of constant term. Okay, so I am writing coefficient of constant of LHS with the coefficient of constant of RHS. Okay, so you can write it as LHS with RHS. Now you see coefficient of constant of LHS. Here since it is 3 terms, x square terms has been gone, x gone, so the constant term is 6. So I can write 6 is equal to, okay, then it has been compared with the coefficient of constant term of RHS. And in RHS what we have? We have AB as the constant. So you can write AB. Okay, so conversely you can write it as AB is equal to 6. What does it mean? It means A is multiplied with B to give 6. And let us take this as equation 3. Okay, so let us take this as equation 3. Now from equation 1, 2, 3 it has been completed. From equation 3 we can get the product of two numbers, A and B are the two zeros. That means the product of any two zeros is 6. जेकोनसी दुईटी संख्यार multiplication is 6. Okay, so let us find out the possible values of a and b. Okay, now the possible values of a and b are, since our first target is to find the value of a and b. Why? Because by putting in this equation we can easily factorize a quadratic polynomial into the product of other two factors. So our target is to find the value of a and b. That's why we are doing this. Now find out the possible values of a and b. Suppose I am taking a to be 1. Okay, then what should be the value of b? Okay, so that their result will be 6. That means these two numbers will be multiplied to give 6. If I am taking a as 1, then what should be the possible value of b? The possible value of b must be 6, because 1 into 6 is 6. Now it is clear. This is the first assumption that we can take. Let us assume the value of a to be minus 1. I can take it. I can take the value of a to be minus 1. Okay. If I will take the value of a is minus 1, what should be the value of b? The value of b, if I am writing 6, then 1 to 6 is 6, but minus sign comes. So I can write minus 6. Hence the result will be 6. This is the second assumption. Now let us find the third assumption. A is equal to a, I can take 2. If I am taking a as 2, then what should be the value of b? So that we get 6. 2 into 3. 2 into 3 is 6. So I can get b is equal to 3. Hence the result will be 6. Or we can get a is equal to minus 2. Okay. Then b will be minus 3. So that minus minus plus 2 3 is 6. So these are the 4 possible values of a and b, and we do not know for which possible value this equation holds good. Okay, so let us find out of this 4 possible value which one is perfect or which one is correct in order to find the value of a and b. Okay, so let us find them. So how can we find the values of the zeros among the 4 assumptions? Okay, so let us find them. Let us first check with the value of the zeros from the first assumption. Okay, so in the first assumption we have a is equal to 1. Here you see a is nothing but the value of the zeros, or you can say a root. And we know if some polynomial has a root or if some polynomial has a 0, it means that polynomial completely divides the other polynomial. Yes or no? Yes. And if it completely divides the other polynomial, then the remainder must be 0 according to the factor theorem, statement 1. Okay, so since we are taking a is equal to 1 as a 0, that means the polynomial must divide the other polynomial and the remainder must be 0. So we have to show whether for a is equal to 1, the polynomial, where is the polynomial? The polynomial will be this one, the polynomial. So we have to show whether for a is equal to 1, the remainder will be 0 or not. Let us check out. So a is equal to 1 is the root, so we have to find the remainder. That means we have to find p of a. Since we have p of a means x square minus 5x plus 6. Clear? Now in the place of a is equal to 1 or a, you can take 1. Okay, if you are taking 1, then it will be 1 square minus 5 into 1, okay, plus 6. It will be 1 minus 5 plus 6. That is, you can get the final result to be 2 here. So do you get 0 as remainder? No, we didn't get 0 as remainder. So can these zeros be the original zeros? No, because we didn't get 0 in the remainder. So we can write a is equal to 1 is not a 0. Because, why? Because you can write because p of a not equal to 0. Okay, then Coming to the first assumption, second part. Okay, in the second part we have b is equal to 6. Okay, now we are checking for only first assumption. So p of 6, it will be 6 square minus 5 into 6 plus 6. So 36 minus 30 plus 6. So the result will be 12. Do you get 0 here? No. Here also do not get 0. So you can write b is equal to 6 is not a 0. Okay. So assumption 1 is not perfect or doesn't hold good. So we cannot go for assumption 1. Let us check the assumption 2. In assumption 2 we have a is equal to minus 1. So now we have to again find the value of the remainder p of minus 1. Then it will be minus 1 square minus 5 into minus 1 plus 6 is equal to 1 plus 5 plus 6, that is 12. Did we get 0 in the remainder? No. So a is equal to minus 1 is not a 0. Similarly, you can go for b is equal to, the second part is minus 6, and find the value of the remainder. It will be minus 5 into minus 6 plus 6 is equal to 36 plus 30 plus 6, it will be 72. Here also we didn't get the 0 as remainder. So we can write b is equal to minus 6 is not a 0. This is clear. So from assumption 2 we get a is equal to minus 1 is doesn't hold or doesn't hold good, and b is equal to minus 6 doesn't hold good. So this has been cancelled. Now let us check the third assumptions. In the third assumption we have a is equal to 2. So find the remainder. It will be 2 square minus 5 into 2 plus 6 is equal to 4 minus 10 plus 6. 4 minus 10 is minus 6 plus 6 is equal to 0. Yes. Here we get the value of the remainder to be 0. Then we can write, yes, a is equal to 2 is a 0. Why? Because p of a is equal to 0. Now let us check with the second part, that is b is equal to 3. So p of 3 is equal to 3 square minus 5 into 3 plus 6. 3 square is 9 minus 15 plus 6. 9 minus 15 is minus 6 plus 6 is equal to 0. Here we again get the value of remainder to be 0. So we can write b is equal to 3 is also a 0. So here we see for assumption 1 and assumption 2, the two zeros doesn't hold good, but in assumption 3 we get the exact value of the zeros. Hence we do not need to find the, or we do not need to examine for assumption 4. Okay, because in assumption 3 we can get the exact value of the zeros. So hence we can write, hence we get a is equal to 2, this is, and b is equal to 3, this is. Okay, so we get a is equal to 2 and b is equal to 3 here. Now our task is to find or is to factorize the quadratic polynomial. What is the quadratic polynomial? The quadratic polynomial is x square minus 5x plus 6. Since we write this quadratic polynomial as the product of x minus a into x minus b. Now we get the value of a to be 2. So just put the value of a there and put the value of b there, and at last you get x square minus 5x plus 6 can be written as the product of x minus 2 into x minus 3. These are the two linear polynomial and this is the quadratic polynomial. Hence, you can convert a quadratic polynomial into the product of two linear polynomial using factor theorem. Okay, so this is the procedure through which you can factorize a quadratic polynomial. Okay. Coming to the second question. In second question we have to factorize this polynomial x square minus 7x plus 12 by factor theorem or by using factor theorem. Since we are going to factorize this quadratic polynomial, as you know, a quadratic polynomial can be written as the product of two linear polynomial, and this two linear polynomial must be the factor of this quadratic polynomial. That means here we are going to write one factor that must be in linear formula or linear form. Okay, and this linear let us coming to the second question. The second question we have to factorize this polynomial x square minus 7x plus 12 by using factor theorem. Okay, so since we are going to factorize this quadratic polynomial, and as you know, a quadratic polynomial can be factorized or can be expressed as the product of two linear polynomial, and this two linear polynomial must be the factor of this quadratic polynomial. Okay, that means this two polynomial must be linear and they must be factor of this. This is the factor 1 and this is the factor 2. Okay, since it is a quadratic polynomial, that means it has two zeros. Okay, since it is a quadratic polynomial, so it has two zeros. Suppose a and b with the zeros. Why we are finding the value of the zeros? Because in this place we will get two factors. In order to find the factors, we need the zeros, because as I had told you, if a is the zeros, then factor will be x minus a, that is x minus 3. Okay, since here we need a factor, that's why we are going to calculate the zeros. Okay, so since it is a quadratic polynomial, then it gives rise to zeros. Okay, suppose that is a and b. This is an assumption. If a will be the zeros, then what will be the factor? Then the factor is known as x minus a. Okay, is the factor. And if b will be the 0, then its factor will be x minus b. Okay, is the factor. Hence, what we get? Hence, we get this quadratic polynomial x square minus 7x plus 12 can be expressed as the product of two factors. What are the factor? One is x minus a and other is x minus b. Okay, now this is clear that the quadratic polynomial will be converted into the product of two linear polynomial. Now we have completed what is the question asked to do, but one thing here, we do not need the, or we do not know the value of these two zeros, a and b. So now we will find what are the value of these two zeros, a and b. Okay, how? As we do in the question 1. How? Simply we will write x square minus 7x plus 12 is equal to multiply this to polynomial using distributive law minus a into x minus b. Okay, so x square minus 7x plus 12 is equal to, it will be x square minus bx minus ax. After opening the bracket, it will be ab. Okay, so the final result is x square minus 7x plus 12 is equal to x square. You can see there are two like terms because they have the same coefficient, they have the same variable and same exponent. So these two terms will be like term. Now let us take negative sign as common and x as common. Since x and negative sign will be taken as common, that's why inside the bracket the sign will be changed. It will be b This sign will be changed to plus a. Okay, now it is clear. Plus ab. Okay, so hence we get x square minus 7x plus 12 is equal to x square minus ax whole into b plus a plus ab. This is the LHS side and this is the RHS side. That means both LHS and RHS will be equal. And we know if LHS and RHS are equal, then their terms must be equal. Okay. If LHS and RHS are equal, then their terms must be equal. That means since it has 3 terms, x square minus 7x plus 12, and it is also 3 terms, x square minus x whole into b plus a plus ab, and these 3 terms will be equal. That's why we are going to compare these terms. How? Let us first compare the coefficient of x square with the coefficient of x square of RHS. Okay, so now we will compare the coefficient of x square of LHS, that is 1. This is the coefficient of x square, that is 1. Here also the coefficient of x square of RHS is also 1. Okay, this is equation 1. Now write the second one. In the second case, we have to compare the coefficient of x of LHS with the coefficient of x with RHS. See it carefully. The coefficient of x is minus 7. So write here minus 7. Okay. Then is equal to coefficient of x of RHS. Okay. Remove x. Then what will remain? Minus. You will write minus. Then b plus a. This is the coefficient of x of RHS. Hence we get, write b plus a first. Negative sign is equal to minus 7. Okay. Minus minus sign has been cancelled. Hence we get b plus a is equal to 7. This is equation 2. Now it is clear. Now let us compare the third term. Since the third terms are the constant terms. Here the constant term is 12. So write 12 here. Okay. And here the constant term is AB. Okay. So write it conversely. Hence we get AB is equal to 12. Or we can write A into B is equal to 12. This is equation 3. Okay. So equation 1, equation 2 and equation 3 has been done. Now what we will do? Now we will see in equation 3. In equation 3, what we have? We have two zeros will be multiplied to give 12. That means there are two numbers. That is, one is A and other is B. And that these two numbers will be multiplied to give 12. So now we are going to find the possible values of A and B. Okay. So what are the, let us find the possible values of A and B. Since we can take A as 1, then what should be the value of B? So that the result is 12. We can write 1 into 12 is equal to 12. Okay, so we can take B as 12. Similarly, we can take A is equal to minus 1. Then what should be the value of B? So that the answer will be 12. Then we can take B to be minus 12, because minus 1 into minus 12, minus minus plus 1 and 12 is 12. This may be the second assumptions. It is the first assumptions. Now comes to the third assumptions. In third assumptions, we can take A to be 2. If we will take A 2, then B will be how much? So that the result will be 10, 12. Maybe 6, because 2 6 are 12. This is the third assumption. Or we can take A is equal to minus 2, then B will be minus 6. Minus 2 to minus 6 are 12. This fourth assumption comes to the fifth assumptions. We can take A to be 3. If we will take A to be 3, then B will be 3 4 are 12. Okay. In the sixth assumption, we can take a to be minus 3, so that b will be minus 4. Okay. Then in the seventh assumptions, we also can take a to be 6, so that b will be 2. But already we have taken b to be 6, a to be 2. These two are quite equal. Okay, here a is equal to 2, here b is equal to 2. That means these are the values of zeros. Okay, here the 0 is 2, here the 0 is 2, here the 0 is 6, here the 0 is 6. So it is no need to write it again. Okay, so there are totally 6 assumptions. Okay, now let us find out of these 6 assumptions which assumptions holds good for our quadratic polynomial. Okay, let us check it. So first we will check for the assumptions 1. Okay, so in the first assumptions what we have? In the first assumptions we have a is equal to 1. Since as you know, this is the 0 or root of the polynomial. That means that polynomial completely divides the other polynomial. And according to the factor theorem, if that polynomial completely divides the other polynomial, then the remainder will be 0. That means p of a should be 0. Hence, we are going to find the value of the remainder. If the remainder is 0, then we can say yes, this is the root of the polynomial. And if doesn't 0, then it is not the 0 of the polynomial. Okay. So let us find p of 1. Since this is our polynomial, okay. So in the place of x, we will put 1. So it will be 1 square minus 7 into 1 is 7 plus 12. 1 minus 7 plus 12. This is plus 6. Is it 0? No. That's why a is equal to 1 is not a 0 of the polynomial. Why? Because p of 1 is not equal to 0. Okay. Now let us check with b is equal to 12. So we will put b is equal to 12. Hence p of 12 will be in the place of x we will put 12. So 12 square minus 7 into 12 plus 12. 12 square is 144 minus 84 plus 12 is equal to 72. Since it is also not equal to 0, that means we can say b is equal to 12 is also not the 0 or root of the polynomial. Okay. Now let us check with the assumptions 2. Assumptions 1 doesn't hold good. So now let us check with the assumptions 2. In the assumptions 2 we have a is equal to minus 1. So we will put p of minus 1. It will be minus 1 square minus 7 into minus 1 plus 12 is equal to 1 plus 7 plus 12 is equal to 20, which also is not equal to 0. That means a is equal to minus 1 is not a root or 0 of the polynomial. Let us check with b is equal to minus 12. So p of minus 12 is equal to minus 12 square minus 7 into minus 12 plus 12 is equal to 144 plus 84. Okay. Plus 12 is equal to, it will be 240. Okay. So it is also not equal to 0. That means we can say for b is equal to minus 12, the polynomial doesn't completely divide the other polynomial, so that the remainder will be 0. Now the second assumptions also doesn't hold good. Now let us check with the third assumptions. In the third assumptions we have a is equal to 2. So let us put in the place of x to be 2. Hence p of 2 will be 2 square minus 7 into 2 plus 12 is equal to 4 minus 14 plus 12. Hence it is equal to 2, which is also not equal to 0. That means a is equal to 2 is not a 0 of the polynomial. Let us check with b is equal to 6. So b is equal to 6. Let us find the value of p of 6. It will be 6 square minus 7 into 6. Okay, plus 12. Okay, then 6 square is 36 minus 7 6 are 42 plus 12, it is equal to 6. That means it is also not equal to 0. Then we can say b is equal to 6 doesn't or is not a factor of the polynomial. So the assumption 3 also doesn't hold good. Now let us check with the assumptions 4. So in assumptions 4 we have a is equal to minus 2. We have to find out the value of p of minus 2. It will be minus 2 square minus 7 into minus 2 plus 12 is equal to minus 2 square is 4 plus 14 plus 12. Hence it will be 30, which is also not equal to 0. Hence a is equal to minus 2 is not a factor of the polynomial. Okay, or not the 0 of the polynomial. Now let us check for b is equal to minus 6. So b is equal to minus 6. P of minus 6 is equal to minus 6 square minus 7 into minus 6 plus 12 is equal to minus 6 square is 36 plus 42 plus 12. Okay, it is equal to 40, 30, 70, 80 is equal to 90. Hence it is also not equal to 0. That means b is equal to minus 6 is also not a 0 of the polynomial. So assumptions 4 also doesn't hold good. Now we will check with assumptions 5. Here a is equal to 3. We need to find the value of p of 3. So in the place of x we will put 3. So it will be 3 square minus 7 into 3, okay, plus 12. Hence 3 square is 9, 7 3 is 21 plus 12. Okay, so 9 minus 21 is minus how much? Minus 12 plus 12 is equal to 0. And finally we get the value of the remainder to be 0. Okay, after 5th trial. So we can say that, okay, we can say that for a is equal to 3, the polynomial's remainder to be is equal to 0. Hence a is equal to 3 is a 0. You can write, hence a is equal to 3 is a 0. Now let us try the second one. B is equal to, here we have, I have erased it, here we have a is equal to 3, b is equal to 4. So let us try b is equal to 4. Now we need to find p of 4. It will be 4 square minus 7 into 4 plus 12. Okay, is equal to 4 square is 16 minus 7 4 is 28 plus 12. Hence 16 minus 28 is minus 12 plus 12 is equal to 0. Then again we will get 0 as the remainder. That means we can say b is equal to 4 is also a 0 of the polynomial. Hence we can write b is equal to 4 is also a 0 of the polynomial. Okay, so at the 5th trial we get 2 zeros. A is equal to 3, b is equal to 4. That's why we need not have to check the assumptions 6. So now finally we concluded that a is equal to 3 and b is equal to 4 are the two roots. I am writing here. Hence what we get, a is equal to 3 and b is equal to 4 are two roots, or you can say it two zeros here. And initially we have written, you can remind x square minus 7x plus 12 is equal to, this is the quadratic polynomial. This quadratic polynomial can be written in the product form of two factor x minus a into x minus b. Okay, and now we get x square minus 7x plus 12 is equal to, in the place of a you should put 3 and in the place of b we will put 4. And this is the final answer where the quadratic polynomial is being factorized into two linear polynomial, or we can say that this quadratic polynomial can be expressed as the product of two linear polynomial where the roots are 3 and